Hey guys, welcome back to another RESK maths tutorial. And in this tutorial, I'm going to be showing you guys what stationary points are, how we can calculate them, and the different types of stationary points which you might encounter when drawing graphs on the Cartesian plane. So let's look at a regular graph such as y equals x squared. If we sketch this out, this is going to look something like this with a parabola shape, just like that. So you can see what we'd consider stationary points, or also known as turning points, are the points where the gradient is changing, sign. So that might be, if you're considering as a turning point, well, it's just when the gradient's going from down to up. Or in a different case, if we had y equals minus x squared, I'll just draw it quickly like this, it's going to look like this. And in this case, this is still stationary point, but this is a maximum. So it's going from a positive to a negative gradient. So turning points basically allow you to quickly sketch a curve. If you don't know really what a curve looks like, you can find out all the turning points and that'll give you a basic idea. For example, if you know turning points of a curve, of a random curve out here, then you might be able to sort of guess that it looks something like this, if it's a quartic, like so. So I'm just going to show you guys how we can actually figure out these turning points as well as the nature, like I said. So this turning point here is a maximum because the curve reaches a local maximum. And this turning point is a minimum because the curve reaches a local minimum. There's actually a third type of stationary point, which I'll get to at the end of the video, called a point of inflection. That's slightly more complicated, but it's not too bad. So how are we going to work out stationary points? Well, what you'll notice is that the gradient at the stationary point is actually equal to 0. So it slowly gets shallower and shallower until eventually at the stationary point itself, the gradient is 0. And we know a way of actually working out a function which is going to return the gradient of the curve at any point, also known as differentiating. So let's take y equals x squared as our example here. I'll just put this over to one side. We'll just put that there. So our example, let's differentiate it using the power rule. Y dash, that's just going to be 2x using the power rule. And this is going to give us the gradient of the curve at any point on the curve, given the x value. So we want to find the x value for which we get this turning point. And to do that, we set the gradient function equal to 0. So we're solving for when the gradient of the curve is 0. That gives us 2x equals 0 or x equals 0. And you can also solve for y by putting this into the original equation here to give you y equals 0. So we know there's a stationary point at x equals 0, y equals 0, like so. So that tells us location of a stationary point. Now, obviously, if we have the graph, we can see that this is easily a minimum. But what if you didn't have the graph? So I'm going to show you guys how to determine if it's a minimum or maximum. And to do that, what we need is a second derivative. So we know y dash is 2x. And now if we take the second derivative, this is going to show us the rate of change of the gradient. Rate of change of gradient. So if the second derivative is greater than 0, then that means the gradient is actually getting bigger. So what that would look like is here we have a negative gradient, and on this side of the stationary point we have a positive gradient. So you can see the gradient went from negative to positive, so therefore gradient is increasing, which is shown by the second derivative being greater than 0, and therefore you can see that this has to be a minimum, because the curve is going to reach a minimum point and then start increasing from there. Otherwise, we have the opposite scenario. So if the second derivative is less than 0, that means the gradient is decreasing. So it's going to look something like this, where the gradient is initially positive, Then after the stationary point, the gradient becomes negative, and at the stationary point, it's a maximum because it's gone up, reached a maximum value, now it's coming back down. So yeah, hopefully that makes sense. And now we can get on to that final case, which I talked about at the start of the video, which is if the y double dash is equal to 0. So if this is true, we can't actually conclude anything. Some people think this is what allows you to conclude a point of inflection, but that's actually not true, because if we look at the function y equals x to the 4, this looks basically identical to the quadratic, except the bottom is a bit more steep. But what we can do is, if we look at we know this has a point of inflection, a minimum at x equals 0, y equals 0, and we could find that using same method we did before, so setting the gradient function equal to 0, and then solving for x, which is going to give us x equals 0, y equals 0. So there's our point. But you'll notice, if we work out the second derivative to try and figure out if it's a minimum or maximum, and then we put in our stationary point, we're just going to get the second derivative as 0. But clearly, this is a maximum, right? So why aren't we getting the gradient, the second derivative is greater than 0? Well, that's just because this has a few extra layers. But what we can do is we can just keep on differentiating until we get something which doesn't give us a 0. So 24x, and then the fourth derivative is going to be just 24, which is greater than 0. So that allows us to conclude that this function at x equals 0 is increasing. That's what you do if you get a 0 and you actually want to conclude. But in some cases it's 0 because it's a point of inflection. And a point of inflection is basically where the second derivative it appears like it's going to change, is when the gradient appears like it's going to change sign, but then it just doesn't. So, for example, if we had y equals x cubed, gradient here is positive, gradient here at the point of inflection is 0, but then gradient after this is still positive. So it's never actually gone negative, it's never changed sign. And this is actually what we call a point of inflection. Essentially when the gradient goes to 0 but then comes back up. And on a gradient function, this would look something like this, where it's not actually going beneath the x-axis, so it never becomes negative, but it touches that point 0 where it's a stationary point. Okay, and you can see this is true because if we take second derivative, well, I'm just going to tell you that this is at 0, 0, just so I can skip actually solving for the first stationary point. But if we take the second derivative, 6x, and then we put x equals 0 into this, we're going to get y dash equals 0, which is a point of inflection. So it's important to note, if it's a point of inflection, then the second derivative will be equal to 0. But if the second derivative is equal to 0, this doesn't straight away mean that it's a point of inflection. So make sure you keep that in mind when dealing with this. And it's only a one-way sort of correspondence. So yeah, these were the different types of stationary points. You should really get used to these, especially when trying to sketch curves, because if you work out all the stationary points of a curve and their sort of natures, then it's really easy to sketch that curve. And yeah, thanks for watching. I'll see you guys in a future tutorial. Bye.